And this is Jim. And from in this week, I will have three training to introduce the ECAM function of our LX5V series PLC. And today is our first training. Let's start. This is our today's content. First, I will introduce what's the ECAM and some application of ECAM. And then finally, the most important part is how to draw the ECAM curve. Part one. Here we have two pictures to show the machine code cam. We can see with the continual rotation of the cam, this part, middle part, we can see the slave. Slave will makes an corresponding movement according to the angle of the cam part. So here, this rotation part is master and this part is slave. So this is the machine code cam. ECAM means electronic cam. So ECAM is a cam table created by PLC software to simulate some similar function, just like machine code cam. And we can easily to see it will be more easy to create it an ECAM, electronic cam curve, instead of creating a machine code cam. And in software, we can design different ECAM curve according to the different application. And also, we can see with the PLC ECAM function, it will be more economic compared with this machine code cam. Some application about ECAM, we can see these two rotary cutting and flying cutting. Here, the master is this one. This one, the master is rotate to feed the board, and the slave, this cutter, the cutter will move according to the movement of the master and cut the boards in a specific position in every cycle. And this is another ECAM application. It's also cutting these wood boards. The difference is in this application, the slave need to will have three segments. First segment, the slave will go speed up to catch the wood boards, and when the slave have the same speed with the wood, the cutter will go up to cut the wood and go down. And at last, this cutter will go back to the orange, to the zero position and wait for next cycle. This another application, S-type curve. We can see compare with this uniform acceleration motion. This S-type curve will make our rods move more smoother and have less impact on machine. It's more stable. Okay, so generally in the words, the ECAM curve is the position relationship between the master axis and the slave axis. From this picture, we can see this is the master position from 0 to 500, and this is the slave position from 0 to here. Biggest value is 200. So with the changing with the changing of the master, with the changing of the master position. Our slave will also changing its position according to this electronic curve. Okay, so understand what ECAM curve, what ECAM and ECAM curve is. Our most important part is how to design the ECAM curve. Before introduced the three way to create it, the ECAM curve, we need to uh, check this instruction first. This instruction DCAM is used to run our electronic cam. And this instruction we have five parameter. First parameter is the uh, input pulse of the master axis. Usually we use the encoder of the master motor to as the high speed input signal. The second parameter is the first address of a data buffer table. And this let table is a very long table. I will introduce it in details. So this is just the first position of let data table. The third parameter is the external start signal, because we have different start way, different running mode of the ECAM curve, and there we have a start way means use external signal to as the start signal. So if we create it, if we configure the start signal, this parameter will take effect. Otherwise, this parameter will not take effect. And the last two parameter is the pulse output and the direction output. We need to connect this to Y terminal to the servo driver to control it as the slave. If S3 enabled, then no, it depends on the start mode we created in data table. I will introduce it later. Okay. Just wait a moment. Okay, so first, how to configure the high-speed input. Here in project management, we have this high-speed counting configuration. So here you can enable the high-speed counter and set the pulse input mode. Here in my device environment, I use a rotary encoder and it is AB phase input. And I set it as 4 times frequency. The PPR of my encoder is 400. So because it's 4 times frequency, so when I rotate the encoder one load, it will give 1,600 pulse to my PLC. Okay, so here, this is the DCAM butter address. We can see this table. This is not the whole table. The whole table is about 40 parameters. I only give this uh, uh, only put these two parts. Here, these two parameters is most important parameters in our data table. This index 3, this address is the function register of our ECAM. Here we have six, uh, seven bit from bit 0 to bit 8, and each bit have different function. For example, here, bit 5 is use external start signal. So if we if for this index 3 parameter, if we set on this bit 5, then this x0, the external start signal will take effect. If here we didn't set on this bit 5, then this x0, this parameter will not take effect. And also this index address 5, this is ECAM start register. Here we can set the electronic ECAM as the periodic ECAM or non-periodic ECAM. Okay. So what's the address? What's the address of this buffer address? It depends on this parameter. The second parameter in DCAM instruction. For example, if you use D1000 here, then we need to configure the function register in D1003, and we need to configure the ECAM start register in D1005. So that's why I said this register is just the start address of this DCAM table. Okay, so now let's continue to our topic. How to design the ECAM curve. In 5B, we provide 3 ways to create the ECAM data. First way is use software to draw the ECAM curves. They have one ECAM function in project management, and we can use it to create the ECAM curve. The second way is directly use demove instruction to put the position information of master and slave to the ECAM curve. And the last way is we can use ECAM TBX list instruction to draw to get the ECAM curves. And today in today's training, I will introduce the first 2 way to create ECAM data, and the next training I will introduce the third way to get the ECAM curve. Okay, so here we can see under the project management, here we have an electronic CAM table. We can right click and click new. Then we will get this ECAM curve. It is blank now because we didn't input any position information. So we can click this data setting. After click data setting, we will get this table. This table we have master position, slave position, and CAM curve and resolution. So each line is the position of the master and the slave point. So the first point is 0, 0. Second point is 100, 200. We can see here we have totally 6 points to get 5 segments. And for each segment, we can set the different speed curve. We have 3 selection: constant speed, constant acceleration, and basis P line. And also for each segment, we can set the resolution of it. The totally resolution of all segments is 511. And yes, so the bigger the solution we set, the better control effect will be. So within 511, we can set the resolution as big as possible. It's okay. So this is the first note. The second note is the master position must be incremented. It means for point 1, the position should be bigger than this point 0, and point 3, the position of point 3 should be bigger than point 2. So yes, so this is the second point we need to note it. And then the last is for each segment we can select different curve type. So with this master position and slave position, here I created three curve with different speed, different can curve. We can see first one is constant speed, and this is the position curve. Position curve between master and slave. Here we have point 0, point 1, point 2, point 3, point 5, and point 6. And segment 1, segment 2, segment 3, 5, 6. Sorry, here 5 segments. 1, 2, 3, 4, 5. And this is constant acceleration. We can see here also we have the point 1, point 2, point 3, 4, 5, and 6. We also have 6 key points. These six points. And also here we have segments 1, 2, 3, 4, 5. 5 segments. The different is the position curve is different because we are using constant acceleration. The first picture we are using constant speed. Okay, and then last is basis P line. But usually we don't use this speed curve. So you can just have a look about the curve, this curve. And okay. If my master rotates 0 and continue rotating, then how can I make this ECAM curve? If you master, it depends. It depends on how to say the master length of your master. If one load, for example, from 0 angle to 306 angle is 1 cycle, then you can set the master length as the 360 angle. For example, your master rotates one load where need, for example, need 2000 poles, then you can set the master length as 2000. Okay. So after we get the list curve, get the list curve of we will need to set the parameter. So here we have a parameter setting button, and after click this, you will get this another table. This table is used to set some control parameter of our ECAM. And I will introduce this parameter one by one. First, table version. This is default 0. We can't change it. And the second here, you can set the start device. We can use D device or R device. These two devices are D register, and here 1000. So it means the uh, relative data will be stored in stored from D1000, just uh, like this here D1000. And the max output frequency is the setting of the slave. Usually we set it as the biggest value to 200,000 hertz. And in this data table, we can set it in index in index 6 and index 7, this parameter. So it means after we use this table to create the ECAM curve, then these 1006 will be set as this 200,000 directly. And also this CAM table execution times, this parameter will take effect when we set the ECAM as the non-priority ECAM. And also its index address is this 14. So it means, for example, if you set here as 2, then after you download the project to PLC, the D1014 will be set as 2 directly. So how to say, we can understand this table as convenient way to set to put the parameter in our DCAM data table. And here, enable signal. Here we have the output Y terminal and the lower limit and upper limit of the sync position. How to understand this? We can see here. For this position, for this application, where is the sync area? When the cutter go up and cutting and go down, this area is the sync area, because in this area, the cutter will have the same speed with the wood board. They will have the same speed to go forward and cutting and go back. So this is the sync area. So we need to set this sync area. So we can use this function sync signal. For example, we after calculate, we will find when the master achieve between 200 and 500 in this area, we need to do the cutting action. So we can use this sync signal to control our cutter to go up. So we can use this signal. And also for this setting, we will have the corresponding index address in our DCAM data table. This is this one, Y terminal and upper limit. So lower limit and upper limit. Later I will show you in program. You will understand it more clearly. And this part enable delayed start and enable specific position startup. These two is two different start way, because in this index 3, I said it's a very important parameter in our data table. Here for bit 1, bit 1 and bit 0. Bit 0 is delayed start enable. Use this. And this start and specified position is this one. How to understand these two different start way? For first, delayed start enable. If we set on this bit 0, what will happen? For example, in this, uh, okay. For example, here, normally, from this point, when the master begin to move from 0, for example, from 0 to 100, then our slave will go from 0 to 200. This is normal start or start from current position will be will display in like this. And if you enable this delayed starts enable flag and set the delayed pause in these two parameters, index 15 and index 16. For example, we set the delayed pause as 200. So what will happen? It will happen like this. With the master running from 0 to 2000, the slave will keep its position, keep in 0 position, not move. And after the master achieve 200 and continue to go forward, then the slave will begin to move like this, just like we put. It's just like we put the slave curve from left to right to move 200 offset like this. So this is the delayed start. Could you understand this delayed start? Okay. And the next, what about this? Okay, here. What about this? Start a specific position. Also, for example, we set it as 400, and we enable this bit 1. Enable this bit 1 and set the specified position as 400 and go back to this curve. What will happen? Instead, before our master achieve the 400, this part the slave will keep in 0 position. And when the master achieve the 400, achieve this point, and the master continue to go forward, the slave will go up from this point. To run this point, this curve. These two is different. These two curve is different. It means we can change a position. For example, we change the specific position as 300. This point. and the master go from 0 to 300. This part slave will keep in 0 position. And after the master achieves 300 and go forward, our slave will go to the reverse direction, because from this point, as the master go forward, the slave will go how to say will reduce its position, but for now our slave is in 0 position, so it will go to another direction to go reverse. So so this setting means we move this point to this point. It's different with the delay start. Could you understand? If we use delayed start from this point, the curve will go like this. Just put this part to here, so it will go continue to go forward if we use delayed start. But if we use this specific start and specific position, the slave here will go reverse and go forward. And after this point, the slave will stop because the cycle already finished. Uh, uh, could you how to say? Could you understand the difference between these two start modes? Okay, and later I will also show these two difference uh, in software. Okay, we can run a program and monitoring the position of the slave and according to the ECAM curve to understand it. Okay, and here last parameter is this enable master axis and enable slave axis zone. If we set on this bit 2 or bit 3, then we can enable these two functions. What the zone master or zone slave means. For example, uh, we have the position relationship between master and slave like this one. Master slave and 1.5 like this. Okay, for example, this is the relationship. This is the ECAM curve between master and slave. And if we set the uh, master zone as 1.2 and set the slave zone as 3.1, then the position between master and slave will be calculated like this. First, slave we set the zone as 3.1, so this is our new slave position, 3s, and we put it to this and calculate this part. And finally we uh, because we set the zone of the master as 0.5. So here we need to do this calculate. And finally, the new relationship between the master and the slave will be like this one. M will be 2.225 as the times as the slave. Okay. So now we can go to the program to show to check it. Uh, Including the memory from beginning. Here here I have already created this ECAM table like this. So uh, when download the project, we need to uncheck. We need to uncheck this. Sorry, we need to check this electronic CAM table. Okay. So this is the DCAM instruction. I use high-speed counter 0 to receive the encoder signal. And here I use D1000 as the start address of our ECAM data table. And M9 as an external start signal. Because here we don't have to use X as the external start signal. We can also use bit address, for example, M2, yes, and Y0, Y1, post output and direction output. First, let's check this. Uh, periodic cam and start from current position. Let's set on this ECAM. And here we set D1005 as 1. What's this parameter? Here. Uh, Here. D1005. We set it as 1, and the 1 means we set on this bit 1. This is periodic ECAM start. So now we will get a periodic ECAM table. And let's move the encoder. Okay, check the cam table. Okay. Now we can see as the master running. For example, this point is let me check. Oh, okay. When the master achieves 320, the slave will achieve 200. You can see this is our first point. And continue. When the master achieves 640, our slave will achieve 50. This point. Yes. And continue. When the master master achieve 1,600. The slave will achieve two 200. Okay, so after achieve this point, our first cycle is finished. And if our master continue to running, we can see the slave will continue to go up according to the curve. So when the second cycle finishes, we can see the slave will stop at 400 because in every cycle, the slave will go forward 200 position. You can see from this curve from 0 to 200, and another cycle. When the third cycle finishes, our slave will stop at 600, and each cycle is same because now we are using periodic ECAM curve. So with the master running, the slave will continue uh, to go forward. And also, when the master go back, now when the master go back, the slave will also go back according to this curve from right side to left side to go back. Okay. So this is the uh, normally in cutting application we use uh, non-periodic cam, but we need to use external start signal. Usually, for example, every time when the sensor detect the ice mark on our package, then the slave will go will run one cycle, and in this cycle it will cut one time, and the next time when the sensor detects another ice mark, our slave cutter will go another cycle to cut one time, because if we always use because we directly use this periodic cam to run the slave, there will be a question if the distance between two ice mark is different in our package. The cutting position will be wrong. It can't cut to the how to say to the correct location. Okay, and now we can try other. For example, this one. Try this non-periodic cam and start after delayed position 1000 pulse. Here, we need to set this D1005 as 2. 2 is this aperiodic ECAM. And also uh, for this start source, I use it as K1. What's K1? We can check it here. 1 means we set bit 0 as 1. Bit 0 is delayed start enable. Okay. Okay, now we can move our master and check it. When the master running, the slave will keep in 0 position. And when the master achieve 1000, we can see achieve 1000 and continue to go. The slave will begin to move. And for example, this key point is our first key point is 320, 320 and 200 because our master have 1000 delayed. So when our master achieve 1000 and 320, we can see the slave will achieve 200. And also we can see when the master position achieve 1960, the slave will achieve 100. You can check it. Okay, now you can see it's 100. And the last, when the master achieve 2600, the slave will achieve 200. Okay, so you can see this is the delayed start. Okay, we can continue to check other mode. Now we check this one. Start in the specified position, and I set the position as 500. And enable this. Here we set D1005 as 2. 2 means here bit 1 is 0, bit 1 is set on and bit 0 is set off. So we will get we'll get 2. Okay. And also let's run our master. You can see now before master achieve 500, the slave will keep its position. And when the master achieve 500 and continue to go on, you can see the slave will go to another direction, Y, because following here, where is the 500 of our master? Is this point, right? So from this point, when the master continue to go forward, the slave will go to this is negative neg reverse direction. And when it achieves negative 50, and it will begin to go, how to say, go forward, because the curve is go up. And finally, when the master achieve this 1600, you can guess where the slave will stop at. You can see here, the slave will stop at least about 100 position, because here our start position is this point, and this and this is about 93. And here we continue to go forward. Our master, the slave will keep here, because now we are using the non-preordained ECAM, and we set the ECAM execution time as 1. So after one cycle finished, the slave will not move anymore. Here, CAM table execution time is 1. Okay. And And we can check, let me check. Oh, this non-preordained came and start by external start signal. Where? Here. And here I use M9 as the external start signal, and check the position of master and the slave. Here, when the master running, the slave will not move because we didn't receive the external start signal. And now, here, I set on M9 and continue to move our master. You can see the slave will begin to move, right? And after wait here. Okay, it's stop and 600. Why it will stop at 600? Because here I set the no, oh sorry, here have a mistake about these words. Here I set the non-periodic cycle times as 3. So every time when we get one external start signal, the slave will run 3 cycle. And we have and I have already and we have already checked here. Every time after 1 cycle, the position of a slave will increase 200, right? So that's why the slave will finally start at 600 because because it is running 3 cycle, and each cycle it increase 200. So finally it will stop at 600. And now when the master continue to running, the slave will not move. And now we set on M9 again and move the master. You can see the slave will continue to run. And after another 3 cycle, it will stop at 1200, right? And check again. We set all of this, set on M9 and set here the external start signal is an rising trigger signal. So here we can set off it, and the slave will continue to move because it's a rising edge signal. Okay. So that's why usually we use external start signal as the for in the cutting, in some cutting application. Okay. And finally we can check this priority can start from correct position, but this time I set the master zone as 1.2 and check the position of master and the slave. Normally when the master achieves 320, the position of the slave should be achieved 2000, but now it's only achieved 100 because we have already zoomed the master. And normally when the master achieves 1600, the slave will achieve 200, but now it's only achieved 50. 75 is here. uh, is about this position because we have already drawn the master. So when the master achieved 1,600 in this curve, the master is only in about 800 position, and then the corresponding position of the slave is about this 75. And finally, when the master achieved 3,200, the slave will achieve this to 200. Okay, so uh, this is the setting of the master zone. If we set the slave zone, it's similar, just where the position of the master and slave will be changed according to this form. Okay, so this is all these parameters I have introduced here. For example, uh, this enable delay start, enable specific position startup, and the zone, and priority cam and non-priority cam. And 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 now we can check this enable sync signal. Here I set the sync signal output as Y5, and the lower limit and the upper limit of the sync position is 400 and 800. And here priority is ECAM. This 64 means start from current position, and this uh, enable sync signal. What's this D1004? It's this position. We can check here. This one, index 4, this parameter, and I set the bit 0, sync signal enable. I set this bit as on status. So we can now we can run our master. And you can see here, when the master achieve 400, our Y5 terminal will turn on. So it means now we have already entered our sync area. And when the master is beyond 800, this sync signal will disappear. This is our setting. Y5, 400 and 800. And in next cycle, when the master achieve 2000, it means in next cycle, our master achieve 400 again. And then you can see in this cycle, it will turn on. And the next cycle have a time where outputs the sync area signal. Okay. And here, uh, for the demove, how to use demove to draw the ECAM curves? Uh, it's very simple. We just directly uh, here we directly use uh, move demove instruction to put the master position select position to our DCAM data table. Because here you can see in DCAM data table from 80, index 80 is the totally segment of our data type, and the index 40 and 41 is our uh, master position of the segment 0, and the index 42 and 43 is the select position of our segment 0, and segment 1, segment 2, one by one. So here we can directly demove, demove the master position, select position of each segment to our DCAM address. We can use this way to get our curve. And you can check the video. M4, because here uh, we have totally 5 segments, so we need to move K5 to this address and move position information to other register. You can see with the master running, the position of the slave will go from 0 to 500 and from 500 to 0. Here, the code is this part. 0, 0, 400, 500, 800, 0, 1000, 200, and 500, 1000, and 600, 0. So the position of slave is 0, 500, 0, 500, 0. And this is what we see in the video. Okay. Uh, let me check the time. And the last part is here I add some content about how to change. Oh, about how to switch the ECAM table. So it means in software we can create it mark up to three table, three curve, and we can use this ECAM cut, use this instruction to switch between different curve. And this parameter, this instruction only have two parameter. First parameter is K1 or K2 or K0, 0, 1, 2, only three uh, it is range. And the second parameter is the start position of the register where we start our position information of master and the slave. Okay. And after uh, after we bounce the position table to this ECAM cards, then we can map this position information to our DCAM table to run it. And how to change? Here in uh, data table of DCAM instruction, and here we have this index 4. The bit 2 of this index 4 is switch the table after the current cycle finished. So, and also in index 31 and 32, we have here we can set the number of the ECAM curve which we want to run in next cycle. So here, if we want to switch the ECAM, we need to set bit 2 of DCAM buffer address 4, set on this bit. And also we need to set the number of the ECAM table in next cycle. Where to set? In this index 31. We can set 1 or 2. And last, also we need to bunch our master and slave position data by these ECAM cards. We can check it in program, okay? Here. First, we set on this M7, and this M7, this part is our ECAM table 1. Here I set the segment as 5 and the 0, and then the master slave position. This is 0.1, 0.2, 0.3, 0.5, 0.6. The master, it will go from 0 to 1600, and then the slave will go from 0 to 1000 and 1000 to 0, 0 to 1000 and 1000 to 0. And here I combined. Here I bound this R1088 and the 38 to CAM table 1. This and set on. This is set on the. This is select the cycle. Select the CAM table in next cycle. D1031 is this one. 1031. This index I set is S1, so it means when the current cycle finishes, our next cycle will run table 1. And also I set K5 in D1004. D1004 here. K5 means bit 0 and bit 2 will turn on. And here mainly we need to turn on this bit 2. Start. Okay. And here, we set this table number as 1. And write the ECAM table by demove instruction. Here, we can see as the master running, the slave will go from 0 to 500 and from 500 to 0. Okay, and now we set on this M5. M5, we will run this, we will write this, we will switch to this CAM table 2. and continue to run our master. So here you can see the position of slave will go to 1000, will change between 0 and 1000, because this is our new ECAM table. And we switch back to this CAM table 1 again and run the run the ECAM. You can see the slave will change from 0 and 500 again, because now we switch to our table 1. So okay, so we can use this instruction, this ECAM cut instruction to switch between different CAM table. And this is our today's training. I will share the program and presentation and training recording to our training group. And okay, and thank you for your attending. See you next time.